Thank you for inviting us back to cover the XtremIO Management GUI with your team. As you remember, we left off our discussion with Gartner's description of the 4 generations of all-flash arrays. Generation 1 on the far left was represented by legacy arrays with the addition of SSD drives for performance enhancements. Block movement and tiering were employed in an attempt to have critical blocks on the best performing drives at the desired time. Generation 2, while still single active dual storage processor design, were the first attempts at all SSD-based arrays. However, these systems generally lacked enterprise SAN features that customers rely upon: thin provisioning, deduplication, compression, and snapshots. Generation 3 systems are still single active dual controller systems that began to incorporate enterprise features, including replication. However, these systems still suffer from legacy architectural design decisions, which tend to produce unpredictable performance results due to post-processing dependencies for services such as dedupe, compression, and garbage collection. Generation 4, Gartner's new category, represents true architectural design changes, true scale-out. Gartner created this new all-flash array category, and we're proud to say that XtremIO is a leader. In less than 2 years' time, XtremIO has become the #1 all-flash array in the market, and EMC's fastest growing product in its 30-year history. XtremIO is true active-active scale-out with consistent, predictable performance. XtremIO provides enterprise features that customers expect from an array: thin provisioning, deduplication, compression, encryption, as well as unique zero-space writable snapshots. Finally, XtremIO is tightly integrated with the EMC storage portfolio, including PowerPath, VMware vSphere, SRM, RecoverPoint, and vPlex. Quickly, and then we'll jump over to the management simulator. XtremIO's building block is called an X-brick. Each X-brick is composed of dual active-active controllers with more than a ½ terabyte of RAM, host connectivity via 8 gigabit fiber channel and 10 gigabit iSCSI, and then 25 eMLC drives of various capacities depending upon the cluster size. This X-brick becomes uniquely scalable via an RDMA InfiniBand fabric to create a shared memory system that distributes data and metadata over the entire cluster. This unique data and the scaling technique allows the cluster to scale from 1 to 2, 2 to 4, and so on. Let's jump over quickly to our simulator and get a real view. After logging in, we're taken to the cluster dashboard. Along the top of our dashboard, we can see that there are additional tabs: configuration, hardware, alerts, monitoring, administration. The main dashboard is broken up into 4 quadrants: storage and performance on the top, hardware and alerts along the bottom. Selecting hardware alerts on the bottom is equivalent to choosing those tabs at the top. For the storage, we can see that an explanation is provided for each of these reported elements. If there's any idea of what we're seeing and what percentage of space efficiency is being created, simply hover over these. In the performance quadrant, we have 3 different tabs to choose from: bandwidth, IOPS, and latency. These are unique from the standpoint that I can now change the history from hours all the way out to a week. Also, I'm able to highlight and zoom into any particular area in which I'd like to gain further detail. Let's jump over quickly to hardware. This provides us with a rack view on the left and then an individual component view on the right. By choosing a component, you can see that I'm highlighted here. I can see the front view, the back, cable connectivity, or in the properties itself, I can actually see the actual SKUs, part numbers. This is very helpful if there's ordering, replacements, or any type of questions from our support team. Let's jump quickly over to configuration. That's what we wanted to see. In the configuration tab, broken out into three sections. On the left, volumes. On the right, my initiator groups. And in the middle, the LUN mapping. Quickly, when I select an individual volume, I can see its properties as presented. I can do the same on the initiator groups by selecting an individual group. Let's go quickly to create our own volume. Again, under the volumes segment, I'll choose add. Simply entering a name, a size, and in this case I'll actually choose to select multiple volumes. I can choose the number of volumes, where I'd like to start my index, again the volume name, its size, and any unique settings here. Once I click OK, I'm presented confirmation and choose finish. I now have these new volumes that I've created highlighted, and again I'm able to select an initiator group. In this case I'll hit map all and finally apply that. That's it. New volumes connected to an initiator group that I've created, mapped and ready to go. Day to day we might be interested in alerts and events. You can see under the alerts and events tab I have these two sections. As we've got a simulator, again not a lot of activity here, but I can choose from a filtering perspective all of the different elements inside the severity, date ranges that I like to do, again in further inspection, and I can sort all of these column headers in any manner. Under monitoring, very quickly I thought lay out a monitor that again the team itself might find interesting, but demonstrates how simple it is. I'll create a monitor, a new monitor, where I'll be interested in SSD endurance. I have a selection of these to choose from. There's my SSD endurance. I'll create a bar chart, and after this I'll be able to choose all of my SSDs, and property I'm going to monitor will be remaining percentage. That's it. Built immediately for me. So again, lands on the dashboard, all of my pertinent statistics in regards to bandwidth, IOPS, and any type of host latency. Hardware description itself, configuration aspects, and all of the alerts and monitoring. Thank you very much.